All right, guys, we're here. I want to take a little bit of a look at Charles' Law, make sure that we're all squared up on how that works. With Charles' Law, we are now going to take a look at our volume and our temperature and what happens when we change one of those and get our new volume or get our new temperature from there. So V1, T1 is our initial volume and temperature going in. We're going to assume pressure is held constant. V2, T2 is our final volume and final temperature as we come out, whether we change one, increase the volume, decrease the volume, increase the temperature, decrease the temperature. The biggest thing with our temperatures is we now need to move everything over into Kelvin, which is pretty simple. We take our degrees Celsius, simply add 273.15 to it, and that's our new degree Kelvin, which we represent by the capital K. Again, just as we talked about with Boyle's Law, when we adjust one, whether it's pressure, whether it's temperature or volume, there's always going to be an adjustment on the other side as well. So we'll take a look at, with Charles, what happens here with the volume and the temperature. If we have a balloon, let's say that is inflated to a volume of 5 liters, and that is at 7 degrees Celsius, we want to know what is the new volume in liters if we raise the temperature to 147 degrees Celsius. Now, the first thing that you should be kind of noticing or taking a look at is, wait a second, we have degrees Celsius. You just told us we need to be in degree Kelvin. That is true. We just simply need to add 273.15 to each one of these to get it into our degree Kelvin. So if we take our 7 degrees and add that, it's 280.15. And again, that's degree Kelvin, so I'll put a capital K. And then if we add our 273 to our 147, we should get 273.15 plus 147. We should get 420.15, and again, capital K for our degree Kelvin. So these are the temperature numbers we want to use, not our degrees Celsius, but our degree Kelvin. So from here, now we just simply need really to kind of cross multiply and then divide. So we'll take our 5.0 liters. We're going to multiply that by our 420 degree or 0.15 degree Kelvin, and all of that is going to be divided by our 280.15 degree Kelvin. And the nice thing with that, we cancel our Kelvin charges out. That leaves us in just liters, which is what we need to know for our volume, for our final volume from there. So if I take my 5.0 times my 420.15, I get roughly 2100. And then if I take that and I divide that by 280.15, I should come up with a 7.5 liters as my new volume. So if I was to take a balloon at 5 liters and I was to take it from 7 degrees Celsius to 147 degrees Celsius, the volume would go from 5 liters to 7.5 liters. Again, that's really what we're doing. We will always have 3 out of the 4 unknowns. All we have to do is figure out which one am I trying to solve for, turn my temperatures into Kelvin, make sure my volumes are in the same units, and then cross multiply and divide, and you should end up with your correct answer. There's plenty of practice problems on our unit guide. Please take a look at that as you continue to keep working on the Charles Law and the rest of the gas laws.